Hello, everybody. Welcome to today's episode of Show Me SaaS. Joined by the usual partners in crime that I have here. Toby, Michael, you want to wave hi?
Hi.
Everybody.
Hi there. Um, uh, Obviously, we've had a little bit of challenge lately with scheduling of the show and getting preempted here and there. So apologies to those of you that are following along. And we're hoping to get back to our usual cadence going forward here. But today's topic for our show is one we have talked about in great detail across a lot of content with a lot of different SaaS providers. And it's often a topic that is almost the start where lots of people like to start the SaaS discussion, even though it's probably not. If you've seen our prior episodes, probably the right place to start a discussion. Lots of people think mostly about how am I going to represent my data in a multi-tenant environment. Like that is like some people, in fact, will say SaaS is just shared compute and a separate database for every tenant, and that's their notion of SaaS. And obviously, that's not our notion of SaaS, but that's what it was probably in the early days of SaaS. But still, if you look at sort of what it means to store data in a multi-tenant environment, there's lots of things to think about. Just about, even if you just said pick one sort of storage technology, even with one storage technology, there's lots to think about. Then you add to that all the different kinds of ways that you can store and represent data, and each one of them sort of have their own sort of twist or wrinkle they add to this whole discussion. And so today's topic is really sort of going to go, as usual, a little wide at first and then a little deep. So we'll eventually get to, we've got background noise here. Hopefully it won't be too appalling here, but we'll get through it. Oh my gosh, what a great thing for these guys to choose to do something in my house. We're going to push through though. So I want to start kind of wider and just start talking about, like, generally, what are some of the things on your mind when you're thinking about data partitioning? And maybe we'll even start with just like, when we say data partitioning, what do we mean by data partitioning? And maybe, Michael, I'll sort of put you on the spot. Like when you think about describing data partitioning to somebody, what do you sort of use? What sort of metaphors or what sort of model do you use to describe it?
Yeah, and I think what I'd like to start with in today's conversation is to note that we're not just talking about databases, right? We're not just talking about a relational database. We're not talking about SQL Server or MySQL or Postgres or what have you. We're talking about any kind of data that you might have in your solution, in your workload, whether that's file data or database data, non-relational data, relational data. So all of them, you have to designate what data belongs to what tenant. So that's really, I think, what I think of when I think of partitioning is how am I going to identify, how am I going to put a wall, a partition between one tenant's information and another tenant's information. And there's different ways to do that in all these different technology stacks, which we're going to get into later. But really, at the end of the day, I also differentiate isolation from partitioning. So just because you have data partitioned and one tenant's data is over here and another is over here doesn't mean necessarily that tenant B can't get over into tenant A, right? That's isolation. But partitioning is really just the logical construct that separates one tenant's data information, again, whether it's file or databases or what have you, from another.
Yeah, and I think of, and we'll get to that, a whole isolation story, because I do believe that lots of people sort of conflate isolation and partitioning. And absolutely, when we're talking about partitioning, to me, it's almost like I think I'm going to land that data somewhere. And when I look at it, there's some way that something denotes which data belongs to which tenant, right?
That some could be sort of discriminator of some kind.
Right. And that could be something that has a mapping to something that's concrete, like an actual database for an individual tenant, or it could be something that's more logical, that is just something that says, yeah, when I look at it, I can sort of figure out which data belongs to which tenant. And I think that's a good call out. I don't know, Toby, do you have, like, for data partitioning, do you have a different definition, or does that kind of fit with how and where you think about it?
No, I think that's valid. I was actually just researching this topic for a partner conversation I had just recently. and watching some video that Michael had done in the past. And one of the things that came up, one of the things he said is what he just said just now, which is, partitioning is different than isolation. Partitioning is how you're bucketing the data, and isolation is just ensuring that those different buckets don't leak across, right? So that I guess those are terms that I hadn't really considered, but I definitely, I totally agree.
And then if we take like the two sort of terms we use a ton and overlay them on top of this whole notion of data partitioning, and we talk about silo and pool, those also have sort of a conceptual mapping to this data partitioning discussion as well. So like, Toby, maybe I'll just keep you on the spot here. Like how, when you talked about talking to a partner, like how would you sort of represent silo versus pool when you think about data partitioning?
Yeah, so it's an interesting concept because I think that there's nuance depending on the layer in your architecture that you're applying the term pool or silo. But specific to data, pool was the question of how do I define it, or how do I?
Yeah, how do you think about, like, if you were describing to somebody siloed data partitioning versus pool data partitioning, how would you distinguish between those two?
I think, silo, it would be, in simple terms, dedicated resources. Pooled would be shared. So, if you've got a single Dynamodb table, let's say you've got all your tenants cohabitating in the same table, versus an individual table per tenant.
Or an S3 bucket, or a mount point to a file share, or a hosted, network file share, or an EBS volume, anything like that.
Exactly.
Yeah, and I guess my leaf blower gentleman is back. I guess he wants to come in just at the right moments. I think that for me, I think about silo and pool kind of in the classic ways we would describe this, which is that however I'm storing the data, if it's stored in a siloed model, the data is probably in some sort of storage construct that is dedicated to that tenant. Like it's not the data is not commingled, at least like side by side, and wherever it's stored, it's in some logical construct that has siloed it. And that's the struggle with this language, because there's lots of different ways to represent it. Is it a table? Right. Is it an object? What is it but generally my point is, when I look at it siloed, how it's accessed, how it's stored is kind of on its own, versus in a pool model, I would probably expect to see the data commingled to some degree, right? Like there would be, this is where we talk about keys and other mechanisms that would say, yes, there's a pile of data sort of sitting there, if you will, and then some view of it couldn't be constructed to say which data belongs to which tenant.
And I think it's a little interesting with data that's maybe a little bit different when you think about, you can have what you would logically think about as a siloed partitioning model, like, for example, a MySQL database per tenant. But all of those databases may be running on shared compute, right? So you have a single MySQL daemon, but then you've given a database to each of your tenants to try and make them siloed, and you have different connections, and they don't talk to each other. But you get this like weird, fuzzy area of the whole silo pool thing. Sometimes with data, you think about it with like some of the network file shares too, right? If you stand up like an Amazon FSx file server, generally there's underlying compute there. You may establish multiple file systems, maybe a file system per tenant that you then mount and utilize, but you may have shared underlying compute. So things to think about. And I guess it goes back to why make such a big deal about the difference between isolation and partitioning? Why make such a big deal about whether the compute is pooled but the logical data is siloed? It's just because we don't want people to think that because they've answered one question that they've answered both, right? We don't want people to say, oh, because I've partitioned the data for my tenants, therefore I'm protected and I won't ever, therefore that is isolation, and it's not, right? So that's the only reason why we try to make these differences, is so we can think through all the ramifications.
Yeah, that's the stuff I feel like the pedantic sort of SaaS people who are working in multi-tenant, and at least in our team, when you're working in this terminology all day long, we get really picky about what we mean by isolation, because to me, isolation is almost a security construct, whereas data partitioning is a storage construct. And yes, they both have multi-tenancy attached to them, but they're achieving different goals. We have the same argument with compute even, right? Like somebody will say, oh, well, I've run my tenant in a separate EC2 instance, therefore it's isolated. Well, no, somebody could still get to it. It's just, it's got better isolation, what better ways to build isolation around it maybe, but it isn't isolated on its own. I guess the other question I'd ask is are siloed and pooled sort of mutually exclusive of one another here, right? Does it mean, because I know I've run into some people, I'll work with them and they're like, we're picking our data partitioning strategy, and they're talking about it like they're picking the strategy for their whole application. We have chosen siloed and we are now siloed storage. That is what we've decided. Can you be both siloed and pooled? Maybe Toby, I'll throw you in that direction.
In the same, I mean, I guess
the same solution. Do I have to be does all my data have to be either siloed or pooled?
No. Yeah. So if I mean, an example of this is even in the, some of the content that we produce, we have, tiering influencing the way you partition. So if the appetite, let's say, or the data being stored isn't terribly critical or something like that, then maybe you could pool together just for operational effectiveness. But if it's, if there's some criticality around it, or if there's just no appetite for commingling with the customer or whatever else, then of course you might pool it. But in our case, we had, I think, basic tier tenants all kind of living in the same database, and then the more premium tier tenants, dedicated infrastructure to avoid noisy neighbor, which I might be getting ahead of myself. I think we got a topic on that later, but that kind of stuff.
Yeah. Well, and it also depends on what kind of, what technology we're talking about, right? And account limits and some of the other limitations of the technologies that we use, right? It's really hard, for example, to do true silo object storage in AWS, because S3, you're not going to be able to create that many buckets. You've got a pretty low limit on accounts for how many S3 buckets you can have in an account. And so the reality is that you may silo your databases, for example, but you may actually use a pooled S3 bucket.
Yeah.
Now, conveniently, S3 also offers really strong isolation mechanisms to make that safe and possible. But yeah, I think I think you could be different by microservice. You could be different by type of data. NoSQL, relational, file, whatever. You could be different by tier, like Toby was just talking about. So I think there's lots of different ways that you could choose the best solution for your customer.
Yeah, and that's a good segue and kind of where I wanted to go next, which is like if you sit down and said, like, what are sort of the spectrum of things that might like influence whether you were silo or pool, or what data partitioning scheme you picked. And I actually feel like there's a pretty long list of things that might mean why you choose one versus the other. Like the worst example to me is somebody who just says, well, our data is super critical, so our whole system is siloed. And I'm like, well, is all the data in your system super critical?
Or classically, well, we're in the financial industry, and therefore everything has to be siloed. And you're like, really? Can we dig into that?
Yeah. And so for me, like, there's some pretty common things to me that shape kind of when I think about this. Like compliance is clearly like a big one, right? Some people have like a compliance boundary in their application, and there's a certain family of data that like is super important to their compliance story, and that might mean we will pick a partitioning model. Doesn't mean you're still picking silo, but you'll pick some partitioning strategy that meets your compliance sort of your requirements. And again, that is for just that family of data. Noisy neighbors, the other one that always comes up here, right? Like, how's the data being consumed, right? Or do I have some relational database and people are running these really crazy, queries against it, or have some analytics or data lake, or I'm doing, and they're they're asking these questions that are pushing the data really hard. And can one tenant somehow easily affect another tenant because when the data is pooled, for example? I guess
that's also where you have to be careful about that nuance of my data is not pooled; it's totally siloed. Oh, except you're running, 50 databases on the same RDS DB instance,
right?
So then you are kind of, then you do have potential for noisy neighbor that is a little bit different, right?
Absolutely. That's where it even gets tricky. Somebody will say, well, I siloed it for compliance. I did a table per tenant. But, oh, by the way, they're still running against the same compute instance. Well, that compute instance is still going to give you a noisy neighbor problem. So what are you going to do there, right? And I guess for me, when I maybe we'll just stay on this noisy neighbor because I feel like it is one of the big ones here. Are there certain things you look for that are like indicators that something might be a noisy neighbor candidate and might be worth kind of teasing out into a different partitioning scheme? Anything? Are there any sort of like flavors of things you see that might sort of let's probe that a little deeper?
I feel like that's standard, observability type stuff. If you're doing as your system starts to come online and get under load, are you starting to see hotspots? Are you starting to see things take longer than they should? In the observability realm, and then that might influence expanding into or changing the partitioning scheme then.
Right. Or, some of the technologies and the services have improved over time, but, there were often concerns about hotkeys in S3 or even in DynamoDB. So if you've got a really high scale workload, which to be honest, many companies don't, but there are some that do. And the ones that do, I think, benefit from really diving into the details of how something like DynamoDB is actually implemented a little bit under the covers so that you can avoid some of the noisy neighbor potential hard problems to solve because of how you've set up your partitioning schemes. Same with S3. Same with some of the other databases that like OpenSearch and some of the other non-SQL databases have a similar kind of idea about how they partition by key.
Yeah, I think, Toby, you said something there that there's sort of two life cycles to picking a partitioning. There's probably more than two, but two that I can think of off the top of my head right now, which is one that's sort of reactionary, which is, hey, I've got this observability data. I'm starting to see bottlenecks somewhere. Maybe I want to start partitioning out my data or partition out certain types of tenants to certain different experiences so that they don't get a noisy neighbor condition. And then there's like, I'm building it net new. Like I'm just picking one of these. I still think sometimes even in the net new stage, you can say, sometimes in your application, like, wow, this is going to be a heavy lift, sort of heavy compute and storage kind of part of my system. We do this same thing on the compute side and say, I might start by offering you a dedicated experience there just because I know it's likely to be bad, and go the other direction, which is, as I learn and get more data about the use cases, I see that really only this dimension of it's painful. So I'm only going to carve out this bit and I'll move the other bit to a pooled strategy to get more efficiency out of it. So it's kind of hedging your bets. Where do you wait, or do you sort of do it ahead of time? And maybe I'll connect this to like maybe the tiering and SLAs sort of part of that. That's another part of this discussion, right? Which is, do I just have an advanced user, a premium user, whatever it is, and I'm going to say to them, hey, one of the benefits you get out of just being a premium user is that I will take this particular workload and I will give you a dedicated experience for that. So you'll never have to worry about any kind of cross-tenant performance issues.
I kind of feel like saying that though is almost undermining your product.
How do you say, let's push on that a little bit. Why do you think that?
If you're acknowledging the fact that there might be noisy neighbors in your product, like that should be something like your tenant should never even shouldn't even experience that, right? So coming out of the gate and saying, hey, just to get an optimal experience, you got to pay me a little bit more.
So I would push back on that, Toby, a little bit, only in that I would say it's like when I buy a free tier version of something, I'm I know that I'm not going to get the guaranteed SLAs. I'm not going to get the throughput I want. I know that I'm getting a bargain because I haven't really paid very much money, and I know that I'm accepting that the throughput of something might be less for me, right? It's like a video. I work with video processing systems,
Sure.
so like encoding and encryption. Like their turnaround for the basic tier tenant on that end-to-end process, because it's shared typically, is intentionally slower.
Maybe it's the marketing spin of this that I'm having issues with. Is like I would never expect to see in marketing material to avoid noisy neighbor.
Right.
We're going to get you at the $9.99.
Yeah.
Like here's all these features that you can buy into. That's cool. That makes sense. But noisy neighbor is like a fault with your product. Exactly. It's a problem, not an additional feature that.
Yeah, I wouldn't be that literal with the term noisy neighbor. I think that's an internal term, but you could say, do you want better SLAs?
Sure. And that's fair. And
then you'd say, by the way, behind that is a noisy neighbor strategy, right?
Yeah.
Fair enough to push back. And then obviously I'm not going to cover it because we talked about it. Isolation is obviously in this same category of things that might make you pick and choose one thing versus another. I will say, and we'll get to this more later on here, but I can see picking a storage strategy for isolation that might mean that the tool I have for isolation lets me achieve the isolation I want. So I feel like isolation isn't just this abstract concept. When you pick a storage technology, there's going to be a range of things that can let you implement isolation for that technology. And the options you have to implement it, sometimes there are none. Right. You might choose a data partitioning strategy that at least lets you implement isolation in some way that aligns with the tooling you have. So
I think another way to kind of tackle this, if we've got, folks out there listening today or scratching their head and thinking, like, give me a cheat sheet. Like, I don't know, where do I even start? And one way to think about it is just think about the 5 pillars of well architected. Right. And as you go through those topics, just with that topic, ask yourself, how does this influence how I want to break, partition out my data for this part of my solution? Right. That's kind of an easy way to say, well, performance, cost, reliability, right. Go down the list. And as you think about those different topics, those are good things to think about when you consider how you're going to partition your data.
Yeah, and you said something earlier, Michael, which is, and I've got a talk where I cover this just a little bit, which is like if we're really talking about organizations that are doing microservices and the microservice is supposed to encapsulate the data, I want people considering all of these things at that microservice level, which technology, which partitioning, which strategy is best for me. And I don't see a lot of the organizations I'm working with, they think more globally about a technology. They think, oh, we're going to go all in with MongoDB or we're going all in with something. And then they just use that across all their services. And there's not an open debate about what's the right storage technology for this particular microservice. It's probably just a pet peeve of mine. So I guess the other thing I want to talk about, well, this is the last bit of sort of abstract, sort of higher level version of this is how does different storage AWS services, so if you just say relational, NoSQL, big data, whatever you want to call that, and data lakes or whatever, file systems, like there's all these different ways I can represent data in different technologies. Are there certain things about those that affect your data partitioning strategy? Is it like relational? What are the things I ought to be thinking about versus maybe NoSQL versus object storage? Are there data partitioning themes that span all of those, or is it now each one's kind of a case by case basis? I kind of have to look at that one in isolation and decide what's best now that I've chosen relational.
I do. I think it depends on the service that you're talking about, the underlying technology. We touched on this a little bit earlier, right? The way that you would partition data in S3 is completely different than the way that you would partition data in Dynamodb, because they're completely different technology stacks. And I think for all of them, you do basically have to kind of think about it, one way or the other, that I guess the only ones that would really be the same is if you think about something like Redshift, which is our data analytics OLAP, data managed service database. It really is a relational database. So essentially, the same options that are available to you in RDS, which is the relational database service, are really the same as they are in Redshift. But other than that, if you look at like OpenSearch versus EFS, like, apples and elephants, right? They're completely different. So yeah, you do have to think about it with each technology and with each tooling that you're using for that.
And with each service this may be just another way of saying what you just said, but each service has varying degrees of support for IAM, right? For native authorization authentication. So another thing to consider there.
Yeah, I think I sort of separated into sort of two categories, which is how do I want to partition the data for like all the reasons I mentioned earlier, which is just like compliance and noisy neighbor and all those other things that we talked about. So I might say, well, which one of those technologies would be a good fit based on some of those considerations? But then the other dimension of the problem that I don't think you can't avoid is the actual design and implementation, and the way that particular technology stores data is typically somehow unique. Yes, there's little bits of common things to relational database, but even Postgres to MySQL, you have different options available to you, right? And so I think once you go down to a specific technology level, then my thought process is more like, okay, I'd like to use this technology, but what tools do I have available to me? And that might, in fact, make me pivot to a different technology if there's one that is close, but gives me better options.
Well, and similarly, like, let's be honest, people are out there to try and, generally out there to run a business to make money. Right. And so cost and maintenance also become really long levers that start getting pulled. And like you say, you may want to do a certain implementation, and then you look at the cost that's going to run you at the end of every month on your AWS bill, and you're like, man, I think I'm going to have to compromise here a little bit.
Yeah, I know for me that like I guess for me there's probably some big matrix of things I think about in my head, but it doesn't all break down into like this natural path of make decision 1, then decision 2, and then decision 3, and I arrive at the technology and partitioning scheme. It's kind of like I have to sort of weigh the pros and cons across a whole bunch of axes, and then say this is a good fit for me. And cost, like you say, cost is absolutely in that equation, right?
Well, and it's why I say, if you're looking for that matrix and you want to start building your pros and cons list, just go with the categories from Well Architected, right? That'll give you a really good start for what are all your columns that you need to start putting checkboxes into.
Yeah, and the space is evolving all the time, and so what you could do like 6 weeks ago, that you might have some new option available to you. So that's always interesting. So okay, so let's pivot now a little bit and say, we've sort of been the hand wavy high level version of just what are the concepts behind partitioning and what are the things you ought to be thinking about. Now let's like just pick one of a few services and like give examples of maybe what your options are in those, right? Like one of the ones we do across all our solutions, the both of you are almost sick of talking about it, but it is the one that we cover ad nauseum across our content is Dynamodb, right? Dynamodb is super popular. Even if you said step back from Dynamo, like obviously NoSQL databases could be in this category, but again, the technology of how they're implemented, Mongo's options for supporting multi-tenant are going to be are different, and DocumentDBs are going to be different, and Dynamo. So I want to stick to Dynamo because Dynamo to me has always been one of the best examples of, hey, it's a native AWS service that has lots of integration with the rest of the AWS stack. And because it has lots of built with that sort of from the ground up, it gives you lots more knobs and dials to build it in. So maybe Toby, I'll put you on the spot. I know you built EKS and used Dynamodb as one of the examples of how you guys store data. Like what are what are the different options you have for partitioning and representing data in DynamoDB, multi-tenant data?
Well, I mean, the Dynamo, it kind of goes back to the point I made earlier, which was, to the degree the service you're using actually supports IAM, and Dynamo has a great story there, right? With the whole leading keys, you could say, you can apply a role and have that role have a specific access to keys that only start with this ID, and oftentimes that ID would be the tenant ID. So the flow from process or compute layer down to the database layer, assuming you've wrapped that in a tenant scoped kind of boundary, you get that more or less for free. So I mean that works great in Dynamo.
Come up a level from that though, Toby, and think about silo versus pool inside of DynamoDB. Like what? Because obviously silo, you're not going to give somebody. You don't have like in a relational side of the world where you'd give somebody a separate database or a separate instance, right?
Well, it's tables, right? Is that the question? Yeah. So, I mean, in this case, you're dealing with tables, which feel like databases maybe, but given that it's NoSQL, you have the ability to kind of stash a bunch of stuff in there that may or may not be relational. But did I address your question?
Right. So basically, Dynamo, we to me to do siloed option is a table per tenant kind of model, right? And then the pooled model is kind of gets back to your
and I jumped right ahead to that. Yeah. So in the pooled model, you've got all of that. If you've got that data kind of commingling, and you've got it partitioned correctly with say tagged with tenant, not tagged has a different connotation, but keyed by tenant ID. You've got nice IAM controls to kind of keep that separate, at the IAM level.
And this is one of the. Go ahead.
Well, I was going to say, there's a recent, not relatively recent. There's a relatively recent push for what they call single table design in DynamoDB, where you don't make a table for each of your sort of domain areas for your whatever your business problem is that you're solving, but instead you treat a DynamoDB table kind of like a database, if you will, and then you use GSIs and indexing technologies to basically give different query patterns into this kind of big blob of data. And I haven't worked with a big enough system yet to kind of understand. So take a single table that's actually multiple different kinds of data, and then apply pooled multi-tenancy on top of that, right? That might be sort of an interesting thing to walk through. And what could you or could you not do with IAM policies to protect yourself in that?
Yeah, I think in that case you'd be subject to, if you're doing the single table design and it forced your hand with respect to what your primary key is and what your partition key is, and it was different than what we would normally do, which is per tenant, then maybe all bets are off.
Right.
Yeah, I think that single table model is one that I'm like you, Michael. We both we've talked about like trying to wrap our head around that. I don't know if I'm just behind the times and everybody just 100% acknowledges that single table is the way to go, or is single table a good fit for some solutions and not for others? That's the bit, and I don't know what, like you say, what's the multi-tenant overlay on all of that, right? Like, does that mean that's okay? I've shoved lots. The data is going to get huge, but I still can partition it by tenant, and it still ends up working out for me. Or no, there's a point at which it becomes cumbersome and not a great fit. But to me, I will say in Dynamo, because Dynamo is kind of a global service, right? The only sort of unit you get is a table, and then you even have to, I think, name the tables globally with a unique name within the region,
or an index, because you can write these IAM policies against indexes as well as because an index also has a partition key, and so all of these things that we talk about at a table level, I think you should be able to implement at an index level. the trick is that indexes aren't free, right? So you got to kind of keep your eye on the dollar bill, so to speak, as part of your design.
Absolutely. But to me, if you're siloed, you can still, the nice part here is IAM gives us, we just have so many IAM like bells and whistles here for the Dynamo environment, because I can say, oh, this table is a table per tenant, and I can put a policy around the table, or I can say, oh no, this table's pooled for tenants, and we can use the model like Toby described, which is we'll actually down to the item level inside of DynamoDB control the view of the data. I do think with Dynamo, there's interesting things also around configuring the throughput here also, like in a pooled environment, right? Because you also get knobs and dials to control throughput. Obviously, in silo and pooled, you'd want to configure those separately for your noisy neighbor and your SLAs or whatever it is you're trying to meet.
Well, and I think a couple of years ago at this point, maybe a year and a half ago, we did come out with some new features where you used to have to basically make that provisioning choice ahead of time, and you would often end up over provisioned and paying for more Dynamo throughput than you would use. And now we have the feature where you don't have to choose ahead of time, and it will sort of scale up to whatever write and read capacity units your queries are consuming.
Yeah. So maybe, by the way, with Dynamo, maybe one of the themes is the more native an AWS service is, the more it's like a ground up AWS storage service, the more likely it is you're going to have the more control over the isolation story. Let's now, as an example of that, let's pivot to the relational side of this, right? Lots of people are still storing data in relational databases. And of course, we say RDS, and it's always hard because RDS still has all these different engines that it supports. And so there's nuances even within the relational space. But maybe, and I know, Michael, you've poked a lot in the relational side of this story. What are my silo versus sort of pool options if we can generalize them? I know you're not going to be able to generalize it perfectly, but if we were to generalize silo versus pool for relational, what would that look like?
Yeah, and it is, and we do talk about this sort of as the opposite end of the spectrum from DynamoDB, because the way that software connects and communicates and talks to relational systems is through the driver. The connection driver that has nothing to do with IAM, nothing to do with AWS, and therefore doesn't have any of the bells and whistles that we get to utilize for a service like DynamoDB. And so you're left with implementing all that yourself. So in a silo sort of pattern, you would find either using different clusters or different databases. We talked about the nuance with databases actually maybe running on shared compute, but fully silo would be independent compute, independent databases or clusters per tenant, and then pooled. You can do pooled in lots of different ways. Like I said, you could pool the compute, but have different databases. You could have a single database, but most relational engines support a concept of a namespace or a schema. So you could have schemas per tenant within a single database on a single piece of compute. That is one way to do pooled. Or you could have a single schema in a single database on a single piece of compute. And that is, of course, completely pooled resourcing. And so I think those are kind of the spectrum of individual to shared resources in a relational world.
Yeah, and you talked about that spectrum of IAM sort of support, right? Like you said, all the good things that we had kind of on the DynamoDB side, they're kind of not like, and honestly, like people will say, well, what am I supposed to do on MySQL RDS? What's my isolation story? And sometimes the answer is you've got to go build your own, right? Yeah. Like
how granular does IAM? I don't know this, so Michael, maybe you know this. How granular is IAM? Is it just you have access to select or not, or
it's not even that? So IAM, there are IAM policies for the Amazon Relational Database Service. So if you go and you look up, it's bookmarked. I go to it literally almost every day, is the actions IAM actions, Google IAM actions in the name of the service, and it'll take you right to what you can write a policy for. So there are actions for RDS, but the controls that IAM is giving you for RDS are really like DBA, database administrator controls. So they're things like, can I execute a backup? Can I delete a backup? Can I launch a read replica instance? Can I change? Can I change my main or my failover instance? It's sort of data.
So it's not
administrator type actions.
It doesn't tie to a user necessarily. So
it ties to an AWS user, but it's really the controls of the managed service. It's not the controls of the database software running in whatever engine you're in.
And the database software doesn't necessarily lift up a database user as a first-class IAMable, if that's a word, entity.
We announced again not too long ago, a couple of years ago, there are some of the engines that now support IAM users. But so I'm not part of the database team, so they're probably going to hate me for not saying that this is the best thing since sliced bread. But essentially what you do is you end up with an IAM user in your AWS account, and then you create a user in the database software, whatever the database software calls a user, whether it's a role or a user or whatever. And then, underneath the covers, you can essentially, like Postgres has lots of different kinds of authentication mechanisms, right? You can use password, you can use MD5 hash, you can use Kerberos tickets, you can use, all these different things, and you kind of tell it which one you want to use. AWS has written an IAM authentication mechanism.
Gotcha.
And so you can tie together an IAM user in your account to an RDS Aurora user, but that doesn't mean that all you've really done is you've now shifted management of your database engine users kind of over to managing them through the IAM console, which is a huge benefit for
sure. Because if you're
like ad hoc access to your databases,
if as part of your onboarding, you're creating an actual database user that has the specific permissions and then binding that with IAM, that's better than nothing.
Better than nothing, right? I think there are limits though. So for anybody out there listening who's interested in this, and it may be a good fit for you, but do dig into the limits. I think the latencies and how you would manage it, right? Like Toby said, you would have to integrate this as part of your onboarding story. To now you got to create kind of stuff in a couple of different places, and it means your connection string and the way that you connect and how you connect is now also something that has to be dealt with as part of onboarding.
Yeah, and I would say this whole mention of user is an interesting sort of tangent here, which is I have seen some people try to use like database per tenant, and then they'll do some mapping of tenants to database users as a way of trying to implementing an isolation scheme. And then somewhere in the process, their connection essentially does a mapping of the current tenant context to a certain user, and then they use that user to open that database. So these are, to me, these are all the things that make me cringe a little bit, but they're also the things that you kind of have to do to sort of deal with the level you have. I would say that probably more people silo in relational databases than they normally would if they had better controls. Silo, they almost fall back to silo, because at least with silo and relational, I can do something to isolate it, right?
Or they pivot too far to the cost and maintenance side, and they give up on isolation, and they pool it, and they don't really isolate it, and they're like, "Oh, we won't have any problem."
Isolation that's the same obfuscation.
Group. That's the same group that says I authenticated, so I'm isolated, right?
So I'm authorized, right? Yeah, exactly. Yeah. Now I will say, and I know, we want to hit on it at some point. There are some technologies in the relational world that do help you implement a rich security story, but they are vendor specific.
Right. Well, so, Postgres, let's highlight it here. I mean, you did a blog post on row and some code around row level security in Postgres, right?
Right. So Postgres has pretty cool controls about that. Again, it's sort of an onboarding story because you got to write the policies and you got to get it right. And Microsoft SQL Server also has their concept of row level security. And I believe, I may be talking out of school, I believe Oracle also has a concept of row level security. The conspicuous outlier, unfortunately, is MySQL and or MariaDB. There is no option for that, and that's unfortunate because a lot of people would love to use those engines and be able to have that same kind of fine-grained security controls, and it's just not available.
I wonder if this is a story that will get better. I wonder if we're as AWS investing there at all, or if that's just a kind of,
this is a theme that certainly we share heavily with our service teams to say, and with IAM, right, that we would like to see these notions of tenant construct and isolation become more natively supported across the stack. And relational database is probably one of the ones where that's most prevalent in an area. But I also sort of realize why there's not a magic bullet answer to it, because if I think about what I have to do to make all that work and still support all the engines and all the way that all the things the engine wants to do, it's a challenging problem.
Sure.
So I do want to go ahead.
Well, I'm going to make one more point. Sorry. If you look, I don't know, back when I was writing code, let's say in 2000, circa 2000, like RDBMS was the only game in town, right? Like you shoved everything into a relational database. It didn't matter what it was. And now there's so many purpose-built databases, most of which probably, at least AWS, are kind of cloud native and built, with IAM probably in mind. So another thing to keep in mind.
Yeah. We won't spend a lot of time on this because I don't want us to get too tight on time here, but obviously on the, just another common example, right? We did note SQL. We've talked about relational. Object storage is the other one that is a really common model, right? S3. I think the options in S3 is that we now pivot back to something that, because it's more native AWS, the tools and the knobs and the dials you have to control its access to there. And then really around S3, it's more like, what are the practical mappings of the number of tenants you have to a partitioning scheme, right? A bucket per tenant's okay if you have a certain number of tenants, but that isn't very practical if you go too far. Then I can do prefixes per tenant. I can do object tags. Well, all right. And I've even seen people do this, and it seems practical to me, is they will put a relational database or Dynamodb in front of S3, and they'll put the keys to the tenants in there, and then they'll use that as a query way to find objects and let the objects be stored wherever they are and make the database the entry point. I think they're all just sort of driven by what use cases you have, but across those buckets, prefixes, tags, there's lots of ways to sort of connect those two IAM constructs for isolation.
And we continue to add different access mechanisms. It feels like every quarter we're adding all kinds of new things to S3 all the time. So keep your eye on the latest and greatest. In fact, I think, didn't we just recently publish a new blog post that digs a little deeper into that? So should search for the latest S3.
Look for S3 AWS data partitioning, and you'll definitely find a pretty recent blog post that tries to go through the options here that are available to you. I do want to hit on one other topic we didn't really have on our list, but I think is one that's worth calling out here. I do get a lot of discussion about keys and encryption in multi-tenant environments. I think it's a whole topic on its own here. But I will say that some people also pick their technology based on some ability to say, hey, I want to be able to per tenant with a tenant level key encrypt my data, and I want to give that key to the customer because they own the data. And that obviously that puts constraints on my support and my visibility into the data and some other things. So you have to sort of accept the operational sort of footprint that comes with that. But I do feel like that's another dimension of this partitioning story, which is what's my per tenant encryption model.
Well, and I feel like it's another, like Toby was saying, all these purpose-built databases and cloud-native technologies. I also feel like some of the encryption stuff is also kind of a rapidly changing space that you gotta keep up with. What features are and aren't available. KMS, of course, the key management service at Amazon is an amazing way to manage your cryptography keys and rotate them and keep them safe and secure. And just about every one of our services supports encrypting data on there, but usually it's not multi-tenant, right? Like you were just saying, like S3 comes out of the box with the ability to server-side encrypt everything. But if you want to do that with a different key, for every prefix or every object, well, now you kind of have to give up on that, and you have to do your encryption and decryption on the client side.
Yep.
So kind of like the relational database story of like, I got to kind of build this myself. But I would keep your eyes open, because it wouldn't surprise me if we don't continue to improve that story on the managed service side. But right now, if you want to get really specific per tenant, I think you have to push that down to the application code.
I just know for some of the highly regulated, financial services, the one that always comes up, right? Or healthcare, some of these other spaces where somebody will say, well, the only way I can sell you a SaaS solution is if you ensure that my data is encrypted. And if my data is encrypted, then I can say, even if it breaks a silo boundary or something else, somebody can't get access to my data. I see that pattern a fair amount. So I do feel like keys are somewhere in this mix of things you have to be thinking about when you're thinking about partitioning. Now, I want to pivot to one harder topic here, which is one that I have struggled a lot with in terms of finding the right answer, which is about sizing environments around silo and pool and so on, which is for some of these technologies, right? The more managed service I am, S3 or Dynamodb, sizing is so not an issue, right? A lot of the serverless technologies are now making sizing not an issue. But for a fair amount of the storage, right, Redshift and other RDS, etc.
OpenSearch. You got to choose ahead of time.
I'm running a cluster. I'm picking an instance size. There's some size to the compute footprint of my environment. Well, let's say now I'm running a pooled environment, and I'm going to run, and the data is going to be stored in pooled storage here. How do I size the instance for that, right? What's the right approach to that?
Talk to your friendly neighborhood specialist, SA.
I think it goes back to observability, right? Like if you've got the appropriate metrics and you've got the appropriate, say, alarms, or it's one thing to collect it, it's another thing entirely to keep watching it or to have something watching it. But if you've got the appropriate observability and you can, with data, say, I'm over provisioned, and despite spikes or despite whatever else, you take the appropriate action. It's oftentimes no big deal to reduce an instance size or whatever, right? Whatever the thing is.
Well, and I think, didn't we recently release a feature with RDS that will help you, just like with EC2, right? That'll kind of watch what's going on and what your patterns of access are, and then suggest whether you need more or less. I think RDS is now doing
I think you're right. Yeah.
By the way, this same problem applies to, like, you could say, well, that's hard and pooled because I don't want to be over provisioned, but I'm trying to size it, and who knows how many tenants are going to onboard today and suddenly make that pooled sizing be wrong. And yes, you can have observability around it, but you're still going to probably have to be over provisioned by some amount to be sure that if there's a spike or anything else, you're not going to be there. So you're going to have cost efficiency challenges there. But even on the silo side, you still have the same problem, which is what's the right size for my siloed customer, right? Like, how do I may be resizing their environments as well based on load. So for me, it means that you just have to face the reality that you may be shifting the sizing footprint of these environments operationally on an ongoing basis. What I don't know is where's the operational sort of agility and all of that sometimes, right? Like there's a point at which I've got 500 customers. Am I watching 500 or 1,000 customers sizing, and am I dynamically sizing them all? It seems like there's a point at which the tooling and the automation has to deal with some of that for me.
Well, and I think you can also leverage the concept of tiering to help, and have different underlying compute instance sizes by tier. And even if your customers aren't choosing the tier, maybe you are, right? Or you align the value proposition of the different packages, the different tiers of your solution that align to cost efficiencies and management efficiencies for you. I'll also point out, if you want to, like, it's a hard problem, and it gets even more difficult with the non-managed service, like not S3, not DynamoDB. But when you talk about having to choose an underlying instance type, which you do with OpenSearch, you do with RDS and Aurora, you do with Redshift, the way that the EC2 world works, there's a combination of both CPU and network throughput with those instance sizes. So sometimes you'll be fine from an IOPS perspective, or from a RAM CPU perspective, but you won't have the throughput from a network perspective, or the ENI attached to that instance type won't be able to take as much traffic as you need. And so that's yet another, point that you have to consider when you're sizing these things, is the network stuff as well.
For sure.
Yeah, and I think this is where I know when Aurora serverless came out, I was like very, very happy, only because I feel like for SaaS providers, anything that takes me away from sizing instances and moves me more towards a pay for whatever you consume kind of model, and that will size dynamically for me, just takes a huge chunk of this problem off the table for me right now. Because to me, like the cost of this could be pretty. You could have a lot of over provisioned environments, a lot of unused sort of capacity on the storage side of this. So you see lots of new services emerging in that. EMR has serverless, I think now. Like obviously, Aurora's released a new version of the serverless.
The new V2 is really starting to come with the features that we would all like to take advantage of.
So my belief is that there'll be a serverless variant of all of these things at some point, and that as long as I get the knobs and dials to let them dynamically sort of scale on their own, suddenly all these sizing issues go away. But for now, I think people have to sort of, especially like Toby said, there's a lot of the world that's was relational, and they probably still are leaning into that relational side. They have to realize when they lean into that, they're biting off these sizing issues, they're biting off these isolation challenges, and so on. So,
well, and we haven't even talked about backup and restore.
Oh yeah,
I mean,
yeah. Well, I think for me, like this was a good sort of broader coverage of these bits. It's clearly indicating that we need to come back now and say, let's do a DynamoDB deep dive. Let's go. And we didn't even touch on, what does it mean to do this for OpenSearch? What does this mean to do this for all these other tool chains, storage tool chains? Because honestly, each one of them is probably an entire episode on its own in terms of what your options are. So maybe that's what we'll do, is we'll come back and sort of dig Dynamo and OpenSearch and Redshift and all of those. We do have good blog posts on those out there on a lot of these technologies that try to do this. But I think that's sort of a discussion of those is good there. And I will say, just you have to bite the bullet on some kind of isolation strategy when you pick one of these partitioning schemes, and you still have to be committed to really ensuring that you have an isolation scheme, even if the storage technology doesn't support what you want. But but I think this gives us a good entry point to that next round of discussion in this, and so hopefully this sort of span enough of that spectrum that you get some good takeaways here, and then we'll just go deeper going forward. But we're up on time right now. Really appreciate everybody joining us today. Toby, Michael, thanks a bunch as usual for being part of this, and look forward to the next episode. Thanks everybody.
Thanks everybody.
Bye.
Bye.